everyone, I hope you are very good. I'm Veronique and I'm back with the new videos on Scope International YouTube channel. So in this channel, videos is going to be focused on the decision tree based on the dissertation of Coca-Cola. So it was focused on the measurements that has been made with the SSPS software, and it was established the node based on the independent variables, root cause of the contract, and vendor descriptions. And I see here through it that the node were totals and also the root of the demand. So if we look here on this decision tree, because I have different decision tree that estimated. On this decision tree, I actually estimate it made the measurement or the performance of the supply. For the confidentiality of the name of the supply, estimated as a supply 2, supply 3, supply 4, supply 5, supply 7, supply 37. And it is a list, actually, the type of root of cause, which was carrier late delivery, responsibility of CCM, demand variable, inventory adjustments, rejections of data, master data issue, master data management, planning parameter, process data not expected, supply human error, supply late delivery, warehouse late capacity. So in those lists of constraints, we have on the decision tree the list of supply from 1 to 37, and each have their own node. In total, I have node 1, node 2, node 3, node 4. And it has been classified each node, the category of supply which is linked to which type of constraint as the higher percentage of issue. So he made the organizations to estimate which group of supply actually has the higher variations of constraints. Following with that, the node of the decision tree also estimates, because there's two types of list of node that has been made, and the second one is focused on the following one, which focus on the formula of ingredient that's been have an issue, the carrier late delivering, the CCM responsibility, demand variations, discontinuation formula, documentation issue, inventory adjustment, lead time are prolonged, load reject, master data issue, new contract, NPR reformulation, optimization planning parameters, supply performance. So each of it actually demonstrates the measurement of which one of this category of constraint has the higher percentage of issue. I won't say which one it is, but and this parameter, I can see the demand variation was the very high, have a higher percentage compared to the others. As you know, Coca-Cola company, if you are seeing in general, has a high volume of demand and projections based on the portfolio. So, and then it classified that in two type of nodes that classified by each of the list of the constraint and make the measurements of the list of the of supply that are lecting, that impacting. And in the conclusion, that list demonstrate that the constraint that has the higher issue was basically the demand variations. So the demand can increase based on the forecasting. That's what we've been talking via the literature review, how much important estimation numeric mathematical model RAN is so important, because it's again estimates which supplier has the most reliable. So following that, and it also can help to estimate anticipate this. And also to the research, as I said, I'm using the SSPS formula, the SSPS software. So on this SSPS software, they actually estimate the test between subjects and such as random descriptions, the root cause constraints, random descriptions, root cause constraints, and the mean square. So they estimate the mean square as well. But I I'm just not going through the whole process of how is what is it and so and so. It's too long. So on this graph, you can see here on the graph chart, which has been measured with the SSPS software, is actually establish the root of cause. Is this establishment of the root of cause list by the variations of the boundary, list the different lists of the boundary, and demonstrate which of the constraint which supplier has the higher average of issue. On this one, if you see on this one, I can see that the supplier, one of the supply had the highest problem of planning parameter. It can depend, as I said previously to my previous videos regarding the cell. There's some of this parameter is happen that the productions quantity physical and the warehouse has a different information than the parameter. That's why an vendor scheduler must always control its parameter master data every day. They must control. It depends the agreement that you made with your portfolio. There's a different list of the portfolio, and your portfolio lists the list of supplies. Depends if every week you have planned to establish the estimations of the forecasting with your supply, and sharing such data between you and him, and also see you can control by anticipate if you can have the goods, the capacity available for shipments, or if it's not capable. So if it is capable to do, then the parameter can be modified, and the quantity to the warehouse must be accurate to the system. So that's why we say that is through the measurement, the demand variations is also a main cause that may affect the variations impacting the parameter. And it is fortunate because here I can tell you which one the supply is, but I will not say who is. So following that, I also estimate the shipments and the purchase order decision tree, and is also established by node, and each node depends of which the higher percentage of purchase order established, and the accuracy of the shipment that has been established. If we see here the number of the purchase order is less than the shipment, so there's a lot of shipment that has been made for this node. Over here the second node is the number of purchase order is high, and then the percentage of the shipment is very high. We can see that the shipment has been established in 100% the final destinations, and some of them have some kind of accuracy that needed to be resetted. So I using the formula chi square to make the measurement of the decision tree from the figure 39 and 40 based on the purchase order and shipment. Okay, so I will not go through it all because the destination is very low. But let me very large. I mean, now let me talk about the master data issue. On this figure, I really established based on the constraint lists, establish the measurements based on which data as the main challenge. And the main challenge that the organization has is the master data issue, and it's regarding the type of EDA system the organization has. So as I say, the ERP are linked to a framework of different tools of technology. In this one, EDI system is basically an online technology where you can actually log in by having a reference and so and so. And in this one, you can see here the reason of that can impact. You can having a problem with the contract or having a vendor problem. So the solution over here is to eliminate any kind of master data. We implementing to the different issue with the estimation of EDA van and EDA VNP. EDR DVNP. So take that, save that in your record. EDR van and EDR DNP. And following that is also the estimation of the using of OTM system, which is the system for logistic and transportations that being linked to subsystem. When a vendor scheduling established create a purchase order via the system of SAP and OTM, there is a link of generations of data between systems. So in subsystem, obviously, when you create the order via the subsystem, you must have a link where you say you give access to OTM to actually create the inbound number. When you have those reference, you can create the inbound number, and that's how, if you can see on the master data or the root of cause via, when you see on this data that has been said the root of cause was the main master issue, is mainly when you create the purchase orders, the vendor scheduling may have need to add or click on one of the keys that has impacting the inbound number. So that's why it's always really important to be linked, and everything has to be set to subsystem, and it has to be linked to the capacity, the way that OTM works. This so, and it's when this is set, it's actually impacting the lead time of transportations, because in logistics they actually, when you create the purchase order and you create the date, you say this is the day that you're going to deliver your goods to the final destinations. They, in logistics, they actually contact the third party transportations, which actually plan the list and create the list for the shipments, and then it let you the outbound and the inbound number, so you know it have the confirmations from the logistic who say the third party transportation agree that the goods is going to be shipped or collected. So by the time that you know that you have on your hand the reference number of the inbound or outbound, and then every time as a vendor scheduling, you must have the feedback from the logistics side based on the purchase order that has been established to track if the good has been delivered on time. That's why the constraint list is so important. And in terms of artificial intelligence, it actually make this a measurement to estimate what is really the case, as has been demonstrated to the disease tree, that the demand variations, the master data was the main issue. And the main issue was basically on the rescheduling time, delivering. For example, you estimate a delivering of good for tomorrow, and then delivery has been anticipated very early, for example, or the delivery of a following IDEA master IDEA data system problem. So that's why anytime any vendor scheduling or master scheduling or logistic establish any process, every parameter through the system must be accurate. So that's why AN vector agglomerate can estimate which of the stakeholder or the technology has the higher, depends the feedback of the constraint to estimate where and why and how must be extended, and how the technology can be adapted to the different type via the supply chain technology. So in order to overcome such issue, we also have the architecture virtual training solutions. So in terms of using different software, it requires us to have the understanding of how to use it. As a vendor scheduling, my duty is mainly focused on using the subsystem. So I have the knowledge of using the subsystem by creating a purchase order and make the link between the generation between OTM systems and return. So this is my duty. In terms of OTM system, this is the main of understanding as a vendor scheduling, because the logistic and then the planning analysis team has worked together. So when I contact my portfolio supply and make the provisions or the capacity of good, the logistic must tell them if the capacity, if they have the vehicle available. So it's always really important to have such information. So through the research, it has been found out that virtual training is the solutions. Like architect of intelligent training environment can classify the virtual environment engine, and it can be made as an avatar transfer, speed, language, system simulation, speech, input, vocabulary, speaker, such as computer, game, and evolve the problem solving as an agent, interactive tasks to support human user. So the advantage of the virtual training make the department planning to be independent and modify information without any assistance. Fortunately, OTM can edit the transportation routes. So it's actually the virtual training solution in avatars obviously have their own speech and language. And fortunately, when you are interacting with us with the technology, you can basically have the capability to reduce any kind of technical problem. Simple because the technology virtual training make you independently anytime during the day be ready to establish the training and be able to use OTM based on reducing any issues such as in the master data. So following that, for example, I'll give you an example of how is the structure of virtual training sources. So this one has been taken from a reference from a research that has been established. So on through it is established the avatar definitions file, the speech of the inputs, the vocabulary, hierarchical ruler, command history, process knowledge base, intelligent agent facility, virtual environment, human model engine, speed recognition, speech synthesis, and expert system process knowledge engine system control. So you see it's multimodal input and track 1 hit tracking job 6 and speaker immense and no immense. So it's how it is as it is. This virtual environment has their own intelligent facility. So by using that, you can actually be able to use the OTM system or subsystem by making the training in the regular day, and based on any issue that you have, you improving yourself, for example in master data issue or demand problem or anything regarding EDI. So anything has to be in the completion. So let me get forward. Like through the research, what so far I've done so far. At the end of the research, I create a software with data, with the data that I had and the data that Coca-Cola has, and based on what I found on the research and based on the analysis. So, for example, I called the system SWAP PM software, and it's actually the SWAP software. It's actually control all the master data that has been consolidated all the database from SAP, OTM, EDI, and warehouse management. This data actually consolidate and centralizing all the data together, and you can identify that through the translations of the different language numerical translation numerical and just through of the project. You can, as I said, given an early example of warehouse technical numerical identification and information. So in this I have the master data will centralize the different system database that come from different sources. So for example, the centralization started with the master with subsystems. So from the different plants, for example, is from Ireland, and it's big database of packaging because my portfolio was focused on packagings and also produce ingredients. So packaging Ireland, drums database, juice basic DBDs database. So I was managed 3 plants. I was collaborate with 3 plants. So 3 plants has their own database. So they have their own software in their own plants. So by consolidate this database centralized to one of the best consolidation database of subsystem OTM EDI warehouse management. It can have been started with the different Oracle because OTM and EDI and warehouse management. The OTM is centralized all the information of CCM, CCC, depends the information that I have. If we are given an information like a solutions, for me, it's OTM actually can centralize all the database or the group of CC. Following with the IDEA system as well, it actually centralize all the information of CCC and the warehouse management as well. So each plant has their own reference and can actually tracking goods. Then you can centralize that in one master data, which can also centralize that in another master data. So it centralizes all the software in one master data, link to also the database of the different planted from different locations. So all each location has their own database that centralized in one software. That software are linked to the different software such as IDEA system, warehouse management, and subsystem. Such information are consolidated, is create like a source key, source data, warehouse data, and master data. And then it creates just one master data. And that one master data is actually consolidated on the BSD master data, virtual DSD data, which has been translating the data. Yes, so this is mainly this based on the subject, virtual artificial intelligence. I manage to estimate the shipment, the measurement of the supply, the root of cause of the supply, establish a mathematical agglomeric results, and conclude and providing this software. So this is the thing is has been and has been sent the final